Hello everyone, today we are going to continue on with our rules for exponents. And when we're doing rules for exponents, it's good to remember the previous rules that we've had. So we've talked about how when you multiply exponents with the same base of different powers, you can simply add the powers together to figure out how many times x is being multiplied. Well, it's being multiplied 2 times here, 5 times here, and that gives us a total of 7 times. We also learned that when you have parentheses, something like x and times y in parentheses, and you raise that to a power maybe of 3, you can distribute that power so that you have x to the third, y to the third. Again, these things only work when things are being multiplied. There's no addition sign between them. Beautiful. Don't forget that distribution also works when you have something like a fraction. It still distributes over the fraction since division is just another form of multiplication. So this would give us 1 to the 7th over 2 to the 7th, which of course can be simplified further. We had rules when it came to what to do with our power of 0. So if I had something like x to the 0, well, anything to the 0 power always give you an answer of 1. And last but not least, we had, or second to last, we almost forgot one here, we also talked about what do you do when you have a power raised to a power. So like x squared to the 5th, well, power raised to a power gets multiplied, so you get x to the 10th. And last but not least, what about things with negatives in their exponents? That moves it to the other part of the fraction. So if it was -2 in the numerator, it gets moved down to the denominator, and we now have x to the 2nd base in our denominator, and that gives us 1 over x to the 2nd. So just keep these all in mind as we look at our newest. Our newest rule has to do with division. Let's say I had x to the 7th over x to the 4th. And I wanted to find a way to write that as one neat little expression. Let's think about what's happening here practically. Along the top, I've got x multiplied by itself 7 times. So I'm going to write that out. 1, 2, 3, 4, 5, 6, 7, x is being multiplied. That's x to the 7th. Along the bottom, I've got 4x is being multiplied. So x times itself 4 times. Now we know that when we're dividing, we're undoing multiplication. So that means that if I have x being multiplied here and divided along the bottom, I can actually cancel that x out. Well, I can do that for every x in the bottom. And that leaves me with 3 x's in the top. In other words, I'm left with x to the 3rd. That is really handy, especially because look at what I'm really doing. I'm taking x to the 7th minus the 4th to get my x to the 3rd power. 7 minus 4 is 3. And this will even work if we have a negative number. So let's think about it this way. Let's say I had x to the 2nd over x to the 5th. Well, I know that if I took my shortcut, I'd have x to the 2 minus 5, which should give me x to the -3. And I know from our rules from earlier that all this is saying is I have 1 over x to the 3rd. It moves it to the bottom of that fraction. And let's look at this practically, like let's write this out and just double check that this makes sense, that we have a reasonable answer here. Well, I know that x squared is just x times x. X to the 5th is x times itself 5 times. And we can cancel out multiplication with division. Notice how here I'm left with a 1 on top because there's nothing up there, and I'm left with 3 x's in the bottom. Well, this is the same as 1 over x to the 3rd. So you can see practically we get the same answer as our shortcut gives us. So we know that subtraction will work. Sometimes you're going to end up with a negative answer, which will bump your variable to the bottom, and sometimes you're going to have a positive answer. You just leave it alone. Let's try these out with a few practice problems. Go ahead and try each of these on your own, and once you think that you have the answer, resume the video and check out the solutions that I have, and those will be starting in 3, 2, 1. here are each of those. Notice that if you are getting these wrong, a common mistake is to write them in the wrong order. Whatever is in the top starts your expression here. So we are going to end up with a 5 minus a 4. So you've got to start with the top. And also watch number 5. Notice that it's a number over itself. So that should cancel out to give you 1. Also, that makes sense because 4 minus 4 is 0, and anything raised to the 0 power also will end with a 1 as a final answer. Last but not least, don't forget that when we're dealing with negative exponents, it should be rewritten so that it is written as a lovely fraction without a negative exponent. Let's try a few harder ones. I'll work through them this time with you. So let's go down. Here are 4 challenging problems. I'm going to skip one of the big ones on the bottom. These problems use all of our rules at once. So when you're dealing with something like this, it's a complete and total mess and can be really hard to work with. So the first thing that you want to do is organize. If you have 2 fractions being multiplied together, you can actually multiply across the top and across the bottom, making this one very large fraction with multiplication signs in the middle. Since we are multiplying on the top, it means that I can multiply in any order that I want. All of this is multiplication, so I can move things around. So that's what I'm going to do. I'm going to organize my information. I'm going to organize it in this way. I'm going to start with all of my normal numbers, not exponents, but my normal coefficients like 2 and 9. And I'm going to put those at the front, 2 times 9. Next, I'm going to pick my variables. I'm going to also cross off my 2 and 9 so I don't accidentally use them again later. I'm going to start by then switching my x's into their own little section in the middle. So I've got x squared times x, which would be to the first power. And last but not least, I'm going to put my other variables that I have to deal with. I have some y's, so I've got a y, which is just y to the 1 if it doesn't say anything, and I've got a y squared. Already, this is a little bit easier to work with than what we had before. I'm also going to organize the bottom of my fraction real quick. It is all multiplication, so I can move things around. And again, I'm going to start by just getting normal numbers to the front. I only have a 3. That would be a normal number. And I have an x, which would be x to the first, and then I have a y to the 4th. Okay, so that's already a lot better. Now what you can do is you can treat each of these as their own little mini problems. This one's just dealing with the coefficients. Can you simplify the coefficients? Well, here I've got 2 times 9 divided by 3. And I want to find out what that is. Now, of course, I can use a calculator. I could do 18 divided by 3. I could also do split the 9 up into its factors and look at it that way. But if you do the 18 divided by 3, we already know that's 6, so we can go ahead and just write a 6 instead. Next, what I'm going to do is I'm going to simplify my x's. This might take more than one step. However, in this case, notice how we have an x squared times x to the first over x to the first. In other words, I'm multiplying by x and then dividing immediately by an x to the same power. That means that these two cancel each other out, leaving me with just x squared at the top of the fraction. This one's a little bit messier. I can't cross anything out because they all have different powers. But what I can do is I can combine my powers. So instead of y to the first times y to the second, I can remember that when I multiply, I just add my exponents together, and that gives me y to the third, 1 plus 2. On the bottom of this fraction, I still have y to the 4th. That has not been dealt with yet, and that's okay, because I can simplify that in the next step. If I have y to the 3rd over y to the 4th, what that really is y to the 3 minus 4, which gives us y to the negative 1. Y to the negative 1 will have to move to the bottom of the fraction, leaving us with this y to the first in the bottom. And along the top of the fraction, I still have my 6 and my x squared. This would be my final answer, because I now have everything combined and simplified as much as I possibly can. Let's try this one more time with the problem on number 3. Again, I'm multiplying two fractions, so I can multiply across the top and across the bottom. I'm going to start by organizing my work, getting my normal numbers towards the front, coefficients towards the front. That brings 3 up to the front. Next, I'm going to take any x's, move them to the second section, which is just going to be a single x from the top of my fraction. And I'm going to organize those y's, so I have y to the 4th times y at the end. Along the bottom, I have no coefficients, so I'm going to just kind of leave an open space there. By the x's, I have x to the 3rd and an x to the 1st. And when it comes to y's, well, I've got a y to the 3rd. I can now simplify each of these pieces. 3 isn't being divided by anything, so it's just going to stay at the top. Here, I'm going to see if I can cross anything out while I simplify my x's, and it turns out that I can. Notice I'm crossing out the x to the 1st. This leaves an x to the 3rd in the bottom, this time, of my fraction. And last but not least, I'm going to have to do some extra work with the y again. This doesn't always happen where x's cancel and y's do not, but it's just happening now. Here, y to the 4th times y will give me a y to the 5th, and I still have a y to the 3rd in the bottom. I'll want to simplify this a little bit more, even though my other two parts are already simplified. Here, I've got y to the 5th over y to the 3rd, so I'm going to do y to the 5 minus 3. That's going to give me y to the 2nd. And since it's a positive 2 as my answer, it's going to remain in the top of the fraction. So I can then write my fraction neatly as, well, I'm left with a 3 at the top and a y squared. On the bottom, I have x to the 3rd. And that is my simplified expression. Now let's look at a few problematic ones. What do you do with something like this? This one, I can't just extend the line across because this second part is trapped in parentheses. Well, the easier solution is get rid of the parentheses. I'm going to start by distributing that -3 to both of the terms inside of here. I'm still just going to leave that x over y to the -1 alone for now, just so I can deal with one problem at a time. So x to the 2nd to the -3rd gives me x to the -6. And that's just because I'm multiplying those together. Don't lose your negatives. Y will then get a power of -3 because it was to the 1st, so multiplying by -3 just leaves you with y to the -3rd. At this point, I can combine across the top and across the bottom. What this is going to do is my x's are already next to each other and my y's are already next to each other, so it won't take me a ton of organizing work. I can just see what I can combine. If I'm multiplying these, and this is x to the power of 1, really, I'm doing x to the 1 plus a -6. Well, 1 plus -6 gives me -5. And along the bottom, I have y to the -1 and y to the -3. So y to the -1 plus -3 gives me y to the -4. We do not like our answers to have negatives. So what I'm going to do is I'm going to take anything with a negative exponent and flip it to the other part of the fraction. In this case, both of them happen to have negative exponents. That won't always be the case. Sometimes only one of them will move. That results in y to the 4th moving to the top and becoming positive, and x to the 5th moving to the bottom, but now positive. That's our final answer. For our final example, I want you to make an attempt at it, but I would like to point out the first step that I took. This one, the only thing that's different from our previous problems is x to the 4th is not written as a fraction, but you can turn it into a fraction by placing it over 1. See if you can solve it, and pause the video while you do so. When you press play, I will have your answer for you in 3, 2, 1. Your answer should be x to the 2nd over y to the 2nd. Notice how you get that. You combine those fractions. The y to the -2 moves to the bottom of the fraction. The x to the 4th minus the second power will give you x to the 2nd in the top. And that turns nice and neat into this lovely fraction at the end.